All right, so we have a pretty big test review sheet in front of you. Uh, I highly encourage you, I may as well type that out so you actually read it because most of you don't listen to the audio. I highly encourage you to write everything down. Any hints you think you need, write it all down. So it's up to you. All righty, so first one, you got yourself an evaluation. This hinges on the old x to the p over r notation, and I really push these for a reason because I think it's your best chance at memorizing this form. So what are we doing here? We're taking the cubic root of a 27, and then we're going to raise that to the 5th power. So, you talk about the cubic root of 27, that's 3, right? So this becomes 3 to the 5th. And 3 to the 5th is when you take a 3 and you multiply it by yourself 5 times, right? It's not 15, don't be that kid. Let's see, that's a 9, that's a 9, that's a 3, so it's 9 times 3, which is 81 times 3, which is 243. Or you memorize what 3 to the 5th is, it doesn't matter. All right, second one. Sorry, I'm not 100% yet. I've got multiplication of a radical. I notice they're both the same, they're both cubic roots. So 4 times 9 is 36. And I may or may not be able to do anything with that. X to the 7th times x cubed is x to the 10th. Put that 10 in the wrong spot. And then we have a y cubed along for the ride. Now this was a cubic root, which means I need to think about factors of numbers that I can take cubic roots of. 36, this may not be the best one to ever look at here. 36 is just 4 times 9, which is 4 times 3 times 3. There's nothing you can do with the 36. There is no cubic root of 36. And it doesn't have any good factors either. Like if 8 went into 36, I'd be in business, but it doesn't. So I'm going to focus now on this cubic root of x to the 10th, which I can write as x cubed, x cubed, x cubed, x. And every one of these cubic roots of x cubed is an x. So I have x, 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 and left inside is that guy right there. That becomes x cubed cubic roots of x. So let's see if I was right. 3 times 3 is 9, add 1 is 10, which is what she was originally. So cubic root, there's an x cubed out front. I need more room. Just erase that. Cubic root, there is an x cubed out front. We also had that cubic root of y cubed, and that becomes y. And stuck inside was a 36 and an x. Ta-da! We have addition. You can only add things if they are alike. So we have x, 4th roots of 48. Now I know that 2 to the 4th is 16, and I know that 48 is 16 times 3. So I can do a little evaluation on this one. I can think of it as the 4th root of 2 to the 4th times the 4th root of 3, and the 4th root of 2 to the 4th is 2. I've already got an x out front, 2x, 4th roots of 3. I'm going to focus on that guy. Bummer, bro. I was hoping this would clean up a little better, but it does not. It's because Milbrath made a mistake. Oh well. There's not anything I can do with it. The 4th root of 81 is actually 3. So plus 3. And I also have the 4th root of x to the 8th, which 4 enters 8 twice, which is x squared. So that's as far as it goes, and there's nothing else you can do with it. Convert 9x to the 7/8 into an equivalent radical. Pay attention to this. The 9 has the understood 1. You got to understand the understood 1 as an exponent. It does not need a radical. Also, some of you guys still haven't quite got none this down, but anyways, and then I'm sick, so if I'm not making any sense when I talk, I'm sorry. But the roots go in the bottom and the power is up top, and this guy has that understood one. So it's sitting outside of a radical. It doesn't need the radicand. Our root is going to be the 8th root, and x is going to be the 7th, or, I can write it like this. A little big on the radical there, sorry. I can put the 7 out there. It doesn't matter, but the power has got to be an exponent. Exponents are high and right, and roots are high and left. All right, 5 is a simplification problem. You're going to use what's called the conjugate to do number 5. The conjugate of 3 plus root 5 is 3 minus root 5. So we'll multiply top and bottom by 3 minus a root of 5. And then we're going to FOIL, right? We're going to FOIL. 1 times 3 is 3. 1 times a negative root 5 is minus root 5. Negative root 2 times 3 is minus 3 roots of 2. A negative times a negative is a positive. Root 2 times root 5 is root 10. It's not that hard. Down low, because of the conjugate, a lot of things happen. We have some cancellations. We have 3 times 3, which is 9. And then we would have take away 3 roots of 5. Then we would have plus 3 roots of 5, and those guys cancel each other out. And we have root 5 times negative root 5, which is minus 5. All right, cleanup operation here. 9 minus 5 is 4. And sadly, nothing in the numerator appears to be where I can combine it. And order is really up to you. I'm just going to leave it the way it is. I don't see the point in really cleaning this up anymore, changing the order. But there she is, and that is apparently simplified. All right. Don't hate me, I didn't make it. All right, simplify this guy such that all exponents are positive. You're going to use your whole idea of x to the negative n is 1 over x to the n, or 1 over x to the negative n is x to the n. You're going to shift things around. And it's not a hard rule, you just don't want to use it. We'll start off with what's supposed to be easy. What's supposed to be easy is 25 over 5, although some of you guys will put it in the bottom, and I don't know, you just do weird things. I don't know how you got this far in math and still don't understand division. I really don't. I should not have to be teaching little things like that, but whatever. So I'm focusing on my x's. And I notice that there's an x to the negative 5th up top. I'm just going to move it down low. And then I'm going to think about this property. X to the a times x to the b is x to the a plus b. So 2 plus 5 is 7. Comes x to the 7th. There's a lonely y to the 6th guy. He ain't going anywhere. And there's this z to the negative 2nd in the denominator. We're just going to shift that thing up top and make it positive. So there is number 6. 7, the one you didn't like. Simplify that thing such there is no radical in the denominator. All right, so let me rewrite it down, and I'm going to break it apart while I'm at it. We have the cubic root of 4x over the cubic root of 9x squared. That's a cubic root. For those of you who still think it's a square root, there's a frickin' 3 there. We have to multiply it by something such that we get a desired outcome. The desired outcome is that it's easy to take the cubic root of 9 cubed. It's supposed to be a 2. And it's easy to take the cubic root of x cubed. So to turn a 9 into 9 cubed, I need a 9 squared. And to turn an x squared into an x cubed, I need an x. So I'm multiplying both the top and bottom by the cubic root of 9 squared x. Yeah. All right, now, this is going to give me 4 times 9 squared, which is 4 times 36. Which is 144, I think. That's not right. 9 squared is 81, right? Yeah. It's 324. So we have cubic root of 324, and x times an x squared. So let's take a look at this cubic root of 324. It should be 27 times 12. Twenty-seven times 10 is 270. 27 times 2 is 54. Yeah, it is. So that's 3 cubic roots of 12. There's a 12 on the inside. There's an x squared. The bottom reduces down to 9x. Last bit of simplification. Over 3x. Now, I did this. You guys didn't like the way I was doing things about a week and a half ago. I'd say, okay, 9 squared is 3 to the 4th. That's how I would do it in my head. I mean, that's how I knew it was 27 times something, because I broke the 3 to the 4th apart. But you guys didn't like that. So whatever, go full-blown number. You pick your poison, kids. I'm too tired to mess with it. It's your grade, not mine. Given f of x is 3x minus 4 and g of x is x squared minus 1, find g of f of 3, more eloquently written as g parentheses, f parentheses, close, close. So, your first step is to find f of 3, not g of 3, f of 3. So here's f. F of 3 is 3 times a 3 minus a 4. It's a bad looking 3. That's 9 minus 4, which is 5. And now you're going to use substitution. Now you're going to find g of 5. Boy, I'm out of it. By looking at g and letting that x be a 5. Well, that's going to be 25 minus 1, which is 24. Final answer. 9, given f of x is 3x minus 4 and g of x is the square root of 4x minus 3, find f of g of x and state the function's domain. So since g of x is the root of 4x minus 3, this is what you're actually doing. You're going to take that root 4x minus 3 and you're going to plug it in for x. Okay, so there's a 3, there's a square root. 4x minus 3 becomes that x. And then there's that minus 4. Don't forget about that guy. State the function's domain. For the root of anything, unless this guy's in the denominator, what's inside is greater than or equal to 0. So 4x minus 3 is greater than or equal to 0. We add 3, counteract subtraction with addition, and then we divide by 4. And there we go. All values of x such that x is greater than or equal to 3/4. Easy peasy lemon squeezy. The domain of f of x equals 0 to 4. The range of f of x equals 2 to 12. State the domain and range of the inverse. Well, I know that inverses swap x and y, or I could say domain and range. So when I talk about the domain of the inverse, f to the negative first of x, it's going to be the old range. It's going to be 212. When I talk about the range of the inverse, it's going to be the old domain, 0 to 4. Just forgive me, I'm still a little shaky, so the handwriting is probably worse than usual. If f of 4 is 8, what is f to the negative first of 8? So I want you to pay attention that this was x and this was y. And this is the notation for inverse. So here we're talking about things being swapped. X became y, so y has to become x. Easy peasy. All right, graph something. Graph a cubic root. You do have to factor and isolate and reduce the radical first. So y is 2 cubic roots of an 8 x plus 2, because 8 times x is 8x, 8 times 2 is 16. And the cubic root of 8 is a 2. So I'm going to evaluate that. I'm going to put it out front. There was already a 2 out front. That becomes 4 cubic roots of x plus 2. This thing is shifted left 2, down 3. And the slope is a 4. Again, you write down whatever you need to write down, but the slope is a 4, so I have to rise 4 and run 1. I also have to fall 4 and run 1. And it's a cubic root. And cubic roots look like this. Ta-da! Here we have on 13, we have a square root. And we're going to do the same thing. We're going to factor first. We're going to pull that 16 from both pieces in the middle. Because you have to have a singular x. We've been over that and over that and over that. You just don't care. That's what it boils down to. You just don't care. The square root of 16 is 4, so it's going to get evaluated and placed out front. There was already a negative symbol out there. And here we have a right 2 and an up 2. And here is our initial slope. So right 2, up 2. And we have a slope of negative 4. 1, 2, 3, 4, and run right 1. And we draw the arm because we know what mom looks like. Because mom was the square root. That's what she was. Shown as the graph of f of x, state the domain and range for the inverse of f of x. And again, inverses swap domain and range. So I guess I should switch over to typing since my hands are so shaky. All right, so we talk about f of x. Its domain was 2 to infinity. Domain is values of x. We've said that repetitively all year long. And its range, the low y value is 3. So it was 3, and it rose forever to infinity. And again, inverses swap domain and range. So now we're talking about the inverse. It would be 3 to infinity. And its range would be 2 to infinity. We just swap domain and range. It's not a hard problem, but so many of you be like, I don't care, Milbrath. I just think you should pass me, Milbrath, because you should pass me because life's not fair. Life is 100% fair. And the same way it's not fair, the same ways it's fair. Most of the reason kids say life is not fair is because they themselves are not fair. Shown as the graph of the inverse of f of x, draw a graph of f of x and state the line of symmetry and the line of symmetry all for all functions and their inverses. All right, so let's talk about function f. She has 2 points that I can see. She's got negative 3 and 1 and 0 and 10. Now her inverse would swap x and y. Remember, that's what they do. They swap x and y. So 1, negative 3 becomes negative 3, 1. And 0, 10 becomes 10, 0. Swap x, swap y. That's all you do. Now, the line of symmetry is always y equals x for least inverses. So anyways, let's do some point plotting. I don't know why I wrote that the way I wrote that. Obviously, I'm out of it. It's supposed to be 1, negative 3, right? To the right 1, and then fall 3, and to the right 10, and go up nothing. And you need your line of symmetry, y equals x. That's just a perfectly slanted line right down through the origin. And remember, you're drawing opposites. You're not drawing the same thing. You know, this was 1/2, sorry, this was x squared, wasn't it? At least half the graph, so this has to be square root. Something along those lines. They have to be the opposite functions because they are inverses. And there you go, kids. 16, use the graph below of f of x equals 1/2 of the absolute value of x minus 3, and g of x is 2 cubic roots of x plus 1 plus 2 to find a couple of things. First one says, where is f of x, which is the v, less than the cubic root? That's a less than symbol. That means below. So where is the v below the cubic root? That happens from here to there. So the x values that make this true are 3.458 to 8.539. And it's a less than symbol, so I cannot have equality. It has to be choice D. Choice A would be inclusion. It would include because it would have equality. Number 2 says, where are they equal? Well, they are equal there and there. So, choice B. Easy problem. 17, over what intervals is the graph of x shown below increasing? Over what intervals is it decreasing? I'm going to type this for y'all's sake. But we are increasing from here to here and from here to here. So we increase from negative infinity, at least as far as x values are concerned, all the way to an x value of 0.2137, union with the other increasing interval, which starts at 3.11963 and moves all the way to infinity. All right, now we can talk about the decreasing intervals. There's only one decreasing interval on this graph. It's this stuff right here. And the x values that make it such are the 0.2137, until we hit 3.11963. It's an easy problem. 18 was probably missed by, probably 90% of all students. I mean, it was bad, which is why I included it. And I guarantee you'll see something like that on your test. But the idea was that weird zeros have conjugates. So my weird zeros, if I scan through this guy or this guy and this guy, they're weird because one of them is imaginary and one of them is irrational. So if 1 minus 4i is a 0, so is its conjugate, which is 1 plus 4i. And if 1 minus the square root of 3, plus, and don't write squirt 3, like don't write that. You literally tell me that you're a blind copier. Use the radical, obviously. Its conjugate, 1 minus squirt 3, is also a 0. So what have I come up with here? I've got 2 new zeros. Let's count our zeros. We have 1, we have 2, we have 3, we have 4, and we have 5 zeros. So these are the remaining zeros right there. Okay. And we have 5 total zeros. This is the fundamental theorem of algebra. We are going to be x to the 5th. 5 zeros, x to the fifth. Now, it actually could be higher than that, because like this guy could be repeated, but it's at least x to the fifth. All right, we are on the calculator part of your test. Actually, I'm just going to stop this video right here. That way I can, otherwise it gets to be a little too long.